Local variables in move are lexically scoped. They're introduced using the let keyword and can shadow any previous local variables with the same name. Local variables in move are mutable and can be updated directly or through mutable references. Move programs use the let keyword to bind variable names to values. The syntax for declaring local variables in move is let x equals 1 with a semicolon. This declares a local variable x and assigns it the value 1. Let x semicolon declares a local variable x without binding any initial value to it. The variable can be assigned a value later. Variable names in move can contain underscores, lowercase letters, uppercase letters, and digits. They must start with an underscore or a lowercase letter. Uppercase letters cannot be used to start variable names. Move allows multiple declarations using tuples. Here's an example. In this example, we see how multiple local variables can be declared simultaneously using tuple assignments. The number of variables declared must match the arity of the tuple pattern. Now, let's move on to discussing scopes in move. Scopes in move determine the visibility and lifetime of local variables. Any local variable declared with let is available within the scope it is declared in. Scopes are defined using expression blocks denoted by curly braces. Local variables cannot be used outside of the scope they are declared in. However, variables from outside scopes can be used in nested scopes. In this example, the variable y is declared within a nested scope and can only be used within that scope. Trying to access y outside of its scope will result in an error. Expression blocks are used to define scopes, and they can contain multiple statements separated by semicolons. The value of an expression block is determined by the value of the last expression within the block. Now let's discuss the concept of shadowing in move. Shadowing occurs when a new local variable is declared with the same name as an existing local variable in an outer scope. The new local variable shadows the previous one, rendering it inaccessible within the current scope. Let's see an example to understand how shadowing works. In this example, we declare a new local variable x within a nested scope, which shadows the previous x variable. The shadowed variable cannot be accessed within the nested scope, and only the new variable is accessible.